Hello, welcome. Welcome to the hackathon. The Reactathon. How's everyone doing? Yeah? Doing good? Cool. Super exciting to have you here. This hackathon is the culmination of a week-long of events that we've put together with a lot of support from some amazing people, our sponsors, our API sponsors, OpenTable, Serverless, Netlify, Roost. If you guys haven't seen the Roost stands, they're really cool. I'm super excited to have James here. Yeah, so who here was at the hiring mixer last night? Yeah, you guys have fun? Yeah. Silence means yes. All right, who here went to a workshop? Cool. Which workshop did you go to? Yeah? How'd you like it? Good? All right, glad to hear that. All right, so let's start this off with a bang. Let's do some raffles, okay? You guys all have a ticket. Just dig her out. We're going super old school. All right. And the winner of the Amazon Echo Dot, which if you're not aware is basically the Amazon Echo but mini version, is number 189062. Yeah. Come on down. You're the next. Fantastic. All right, hold your horses. We got another prize to give away. All right, James is giving away a Roost stand. So, the winner is 189128. All right. Cool. Congratulations.
Thank you, man.
All right, good. Okay, and now you're going to have to hack to get the rest of the prizes. All right, so what is this hackathon about? Learning. We all love React. Most hackathons are, use whatever technology you want. This one is obviously you can use whatever technology, but just we encourage you to use React. You don't have to, but it's Reactathon. So we're about community, education, growth, working with one another. We're giving away prizes, and we want this to be a competitive event. We as developers aren't necessarily competitive to be ahead of the market. But I encourage you all to work with one another, to answer questions, and don't be afraid to ask questions. React and the extended ecosystem is still very new. So we don't want you to be afraid to ask questions. We have a number of tutors and volunteers. If you could all please raise your hands, stand up. These are React experts. They're here to monitor the Slack channel here. You can see this Q&A, different technologies. Feel free to ask a question there if you're running into any trouble. If you need them to come over and work with you, they will do that as well. So let's have a round of applause for our students and volunteers. And feel free to ask questions in general or answer each other's questions. So we can all be tutors and experts for each other and grow together. So we want you at this hackathon. But first of all, let's say what it's not. This is not Disrupt. We're not competing for $50,000. We're not building a startup. We're here to have fun, learn, and win some prizes in the process. Meet new people. I met my current business partner, Berkeley, at a hackathon. So maybe you guys can do the same. Or just meet a new friend. But with that, that's pretty much all I have to say. So we're going to get right into, well, actually, a couple of things. So some of you are having issues with the Slack channel. Can you raise your hand if you are not in the Slack channel yet, in the Slack group? Okay, sorry, the link expired unbeknownst to me, and apparently you can't create a new one. But fortunately, John Wong from Coursera used some excellent hacker skills to allow you to sign up. So go to this link, bit.ly 2L, those are zeros, 06A02. And that will give you the Slack invite. If you're still having issues, you can email me, ben@realworldreact.com. One more thing, has everyone reviewed the GitHub repo Reactathon 2017? That's going to have all of the APIs listed there with instructions, docs, all of that. Obviously, the tables are over there, so you can speak with them there. Some more information on judging, the full schedule, and teams if you want to list your team. You can also communicate with the API sponsors through their dedicated channels. So Netlify is here, OpenTable, and Serverless. And if you want to communicate with James from Roost, he has the Roost laptop stand there as well. Demos or videos, I don't think anyone posted them other than Netlify, but the doc should be sufficient for most of you. All right, so with that, I'd like to welcome to the stage to give a pre-keynote Raj from OpenTable.
All right, thanks, Ben. Can everyone hear me at the back? Yeah. Cool, thanks. How many are planning to stay tonight and do a night out for hackathon? No? Okay, that's not too many. How many are planning to have fun overall? That's good, very good, very good. So I'm here to talk about APIs intros, but before that, I want to talk about the financial forecasting models with a good amount of statistical information to begin with. And I'm just kidding. I'm not doing any of this. So I think usual question is, hey, OpenTable is all about dining. Why do you have APIs? Just eat and be happy. Well, we do have APIs. We've been having these APIs for quite some time. And there are quite a few business partners that we integrate with. It's been a long time. Recently, in the last 6 to 8 months, we've rewritten the whole stack, and we have a new version of the APIs that's being used. Not many may know that we are integrated with Google, Apple, Microsoft, Yahoo, TripAdvisor, Amazon, and several others. The API itself is being used in many different applications. If you're booking for a hotel, at the same time, if you're looking for restaurants nearby, then these APIs are being used at this time. Right now, we are getting about 1.5 million calls per week, which is not a lot, but just the initial phases. Significant share of reservations and revenue are coming from this API stream at this stage. Right? Now, this is the first time we are opening it up to general public. Right? And in fact, in Reactathon, this is the first time we are even exposing this API. So you are the first few babies who are going to try this out. Feel free to let us know what your feedback is, how you like it, what you don't like. Don't hesitate at all. I hope you won't be crying as bad as this. So we have two APIs, and I think that's something to watch out for. One is our traditional REST-based API, which most of these business partners have integrated with, but it's Reactathon, and we thought, why not introduce GraphQL as well? How many have worked with GraphQL so far? Handful, but it's a pretty cool technology. It's also emerging quite a bit. So we do have GraphQL endpoints. There are minor differences between these two. Of course, GraphQL has been in production for the last 2 days. Just before this, it took some real heroic efforts internally to get this up and running. We have limited support. We have very few data points that are available with GraphQL, but it's still functioning. It's still working reasonably well. On the REST API, you could do search, you could make reservations, you can modify, cancel, you can do all of those. And you also have a sandbox environment. It's called OTQA, OpenTable QA environment. Whereas here it's production environment. So be a little bit cautious how many times you hit. If you're hitting too many times, we'll start blocking you. That will block everybody else. So please be a little bit careful in using the right-hand side. All right. So a few quick tips before we show the API itself. You will find a documentation link as part of the repo which Ben shared. And try to replace OpenTable.com with OTQA.com. I think the documentation is still being refined for general use. It's also the demo time. So let me open up. So it's a fairly complicated process of 2 steps. One is you get authentication token, and then you call the API. It's as simple as that. The first thing you do is you call OAuth API. And of course, the user ID and password, all of this is available as part of, sorry, I'm not showing the right one. So all the user ID and password is available as part of the documentation that we have in the repo. Call the API, you get a token, and then you use the token, you can get a list of all the restaurant IDs. I'm not certain if it's visible. Yeah, I don't know if you can tell, but you have a list of all the restaurant IDs available as part of this API if you call /listings. You can also search for availability. You can provide lat long if you know a certain location, and you can provide a radius, and you can, I want it within the next 20 miles, 30 miles, whatever the radius is, and that should give you a list of restaurants. This is a sandbox environment. You don't have the complete production data as you would normally have in production. But this should be sufficient enough for the Reactathon at least. Okay. And so that's the API endpoint. So we also have the GraphQL endpoint, which is even sweeter. So you could give a restaurant ID, and you can specify your schema and what data points do you need, and you get all of the data points available directly. Right? All of this documentation about the REST API is available in here. And we have given the links for the GraphQL API as well. Okay. So I think that's all I had. Happy dining and coding here. Okay. Thank you.
Thank you, Raj. And again, if you have questions about that, you can visit him at his table or communicate with him in Slack. Update on that bit.ly link. Those were not zeros. Those were O's. And all caps.
If you go to bit.ly/Reactathon2017-Slack, that'll get you to the
bit.ly dot
/Reactathon2017-Slack. I'll open it.
Cool. All right. So our next speaker is a software engineer at Serverless. Let's give it up for David Wells.
Hello, everyone. How's everybody doing today? You ready to do some hacking?
Yeah.
You guys are a lively bunch. A lively bunch. All right. This is a cool mic. I feel like I'm on like a radio show or something, like an old-timey radio show. Yeah, see. Okay. Let's see. All right. Cool. So yeah, thank you to Reactathon for having us here, and thank you to GitHub. I always wanted to talk about code in GitHub, so my dream has become a reality. I'm here today to basically introduce the serverless concept to you guys and give you guys an actual demo of what you can do with serverless. And we're here all weekend, so if you have any questions, find us at our table or ping us on the Slack channel, and we'd be more than happy to help you. I'm David Wells. I'm a full-stack JavaScript developer working at Serverless here. We are hiring. Check out our website for what we're hiring. But yeah, previously I worked at MuleSoft on the UI UX team, and I'm a React fanatic. How many people here would consider themselves full stack developers? Okay, a lot of people. How many people here front end developers? Okay. How many people here use React? All right, that's pretty good. How many people here use Angular? Security. Okay. Yeah, I actually was going to do a jQuery joke, but I thought that was mean. I still like jQuery. It holds a special place in my heart. So how many people here have heard of AWS Lambda? Okay, cool, a good amount. So yeah, we're going to talk a little bit more about that today and about kind of how serverless fits into that picture. How many people here have had to deal with node servers setting up node instances either on Heroku or in AWS? Had to use NodeMon to monitor your application to make sure it's running, set up load balancers, basically do a lot of DevOps stuff for your application. That was a long question, but yeah, a lot of people. Okay, so it can be rather painful to do that, especially when you're trying to move fast and build quickly. But basically, I'm here to show you a new way in which you can build the backends of your applications. So first, a little bit of history. Like, how did we get here? How did did people build infrastructure as the years went by? Way back in the day, you'd have to build your own box and set up your own machines, put them in your own warehouse. A little bit down the line, we would actually rent space in one of these warehouses because we don't want to. Everyone can't build a data warehouse. A little bit further down the line, we started running virtual machines in the cloud. Again, kind of renting space. It transitioned more recently to kind of a container-based approach with Docker. But I'm here today to talk to you about kind of what, in my opinion, is the next evolution in compute, which is going serverless. And the reaction that I typically get when I say that is this. Serverless, that sounds like it's made up. And the typical reaction that I see is, there's servers somewhere. There has to be servers. It's impossible to run code without servers. Yes, that is true. Really, the serverless movement is about not having to worry about those servers, not having to maintain them, do security patches on them, or scale them yourself. You can really focus on the business logic of your application and kind of push some of that DevOps stuff off to the provider of your choice. And the other rebuttal I have when people, have a problem with the name is wireless internet really wireless? I can guarantee you somewhere in the room there's a router with wires connected to it, but that's all abstracted away from you. You don't really have to think about it. It just works. Same with the cloud. Is it really a cloud? Who knows? The jury's still out on that one. But yeah, so serverless. So quite simply put, it's running code on demand. You can write your code, deploy it up to one of these many fine providers. So as you can see, some of the largest tech companies in the space are basically offering what are commonly referred to as a function as a service platform, if you will, where basically you can write your code, deploy up those functions, and it just works. You call it, whether it's a REST API or a cron job or an IoT WebSocket, you can basically run that code on demand. And this opens up basically a new realm of possibilities for developers to both move fast and build more robust kind of event-driven applications. So some of the core concepts around building in a serverless way, we see basically people building in a microservices type approach. So instead of building a large Express application that has to be deployed all at once, we see our users and just people building serverless apps out there in the ecosystem, breaking those down into separate boundaries and deploying those up as microservices. So you kind of get all of the benefits that fall out of a microservices approach. Like teams can write in any language that they want, they can deploy independently, and your system can basically grow faster and you can do more things. Another kind of key piece is, it's auto scaling. We don't have to worry about setting up a load balancer in front of it. If we hit on the homepage of Hacker News or the New York Times, we don't need to worry that our app is going down. All that stuff is handled for us by the provider. Another kind of core concept is moving more to an event-driven kind of paradigm, where you can think about, very similar to what we're seeing with Redux in the React ecosystem, things that happen in your application are events. Those events can then trigger other things that happen in your application, and you can react to those events. And then, it's basically a focus on your application code, not on infrastructure. And another kind of key piece is it's actually pay per execution. So instead of paying hourly for a box to run, or basically you pay monthly for like a Heroku instance or a DigitalOcean box or an EC2 instance on Amazon, you only pay for when your code is actually run per millisecond. And we'll talk a little bit more about that in a little bit. So now the typical reaction that I get is this, which is, what? That sounds like some hipster stuff. That's censored for this talk. Why would we want to do this? Why would we want to do this? Well, basically, the way that it works is, like, honestly, you just write your node code as usual, normal JavaScript functions. You deploy that up to the function as a service provider of your choice. Again, Google, IBM, Microsoft, and Amazon. There's other providers out there as well. So you can really choose where you want to run your code. This also opens up the concept of multi-cloud kind of infrastructure, where if you wanted to use something in Google, you're not necessarily locked into, let's say, AWS. And we're seeing some really interesting stuff happen in that space. So you deploy up your code. You only pay when it's run, like I mentioned. This is actually, I believe all of the pricing models are similar for all the providers, but the first million invocations of your code per month are free. So if your app has more than 1 million API requests, I think you can afford to shell out some cash. And that cash is 20 cents per million requests after the free tier. So extremely, extremely cost efficient. And yeah, that's kind of what sold me on this whole thing before I even started working at Serverless. I want to build things, not worry about it scaling, and I want it to be cheap, especially if nobody uses my app but me and my mom, which is typically the case. Who here has that problem? Yeah. Talk to me after. We have a support group. So basically, and it automatically scales for you. So if it's not being run, you don't have to pay for it. If it is being hit a bajillion times, that'll scale out for you and be pretty cost effective. And this makes developers happy. At least it makes me happy, much like this dog. So very, very simply put, this is kind of the equation that I wrote. Your code plus the serverless CLI, which I'm going to talk about here in a second, plus a provider of your choice, equals basically an infinitely scalable backend that you only pay for when that code actually gets called. It's just kind of a more cost-effective solution. And here are some success stories, if you will. There's a ton of these. We have a bunch of case studies on our website as well. But if you just search Twitter for the word serverless, you're going to see people complaining about the word, and you're also going to see tweets like this, where basically this person took a $200 a month server and replaced it with a cron job that's now only like costing them $200 a month. And cases like this we see all the time. Yeah, it's just, yeah, out there for everyone to check out. So what are some use cases? What can I do? Like what can I actually do with one of these functions as service providers with serverless functions? And really, the use cases vary. Honestly, you can do anything you can do with Node. You don't have to write in Node either. Like I mentioned, you can write in other language runtimes. Out of the box, AWS supports Python and Java, and you can shim Go and Rust and a bunch of other languages. I can bet my bottom dollar that most languages will become first-class citizens at some point. But we're React developers, and JavaScript is the best, right? All right. You guys are so enthusiastic. Yeah, so some of the use cases, like, creating your web backend. So your API that goes and connects to a database that grabs the user's to-dos and spits them back out to your UI, which I can imagine some people will be doing today. You could absolutely do that with a Lambda function, talking to any database service you want, or with a database that may live in AWS or any of the other providers. They're kind of proprietary solutions. Form processing, image processing, web scraping or testing. So you can run binaries. Because it's Node, you can run Phantom.js, and I can go and scrape a website and check my latest sports team score to check that they're still #1 in sports. You can tell that I watch sports with that example. But yeah, and it doesn't need to return JSON for like an API request. That's just one option. You can return HTML. You can return a dynamic SVG. You can basically set the response type to whatever you want. That opens up some really interesting possibilities. And one of the things that I actually would love to see today is basically some server-side rendering with a Lambda function, because all it is Node. You can server-side render React. So hint, hint, prize money, etc. You can set up webhook listeners, which is really just an API. You can do cron jobs. So, if you've ever set up a cron job on a box, it's running hourly. You're only doing work when that cron actually hits every hour, every day or whatever. You're paying for so much idle time with those cron jobs that if you switch to this type of model, you only pay for when it's invoked per millisecond. So we have a cron job running every hour, every day for some blog stuff we have going on. And so it's only running $720 or 720 times a month. So it's well under the free tier. We don't pay for basically our custom kind of thing to run. So you can imagine that this opens up a world of possibilities, not only in your professional careers, but also for like doing things at home or doing side projects or automating your house, etc. Like this slide, I put so many things on here because you can really do whatever you want with it. And that's why we're so happy. Everything. Oh, but there's an asterisk. What's the asterisk? The asterisk is basically one limitation. There's one limitation, and that limitation is anything that runs longer than 5 minutes. So if you have a function that runs longer than 5 minutes, which if you're building a backend for your UI and you're doing a request that takes longer than 5 minutes, you got some usability problems. But yeah, basically if you're doing like some really heavy machine learning or just really data intensive stuff, there still is a use case for spinning up a server to do that long-running task to basically return that data at a given time. That said, there's no reason why you couldn't use Lambda to actually receive that request for the batch process and then use that Lambda function to spin up an EC2 instance in your AWS account, do the long-running job, then spin that EC2 instance down, and send the user an email, hey, your batch job is done. So a couple of examples. This is one of my favorites out there. And this is going into this kind of event-driven paradigm where this example application is actually a user uploading an image That image goes directly into an S3 bucket. S3 is Amazon's storage solution. And you can basically react to infrastructure events. So if a new file is put into your S3 bucket, you can trigger a function based off that. So in this example, he is listening for a new image in the bucket, then running it through a Lambda function, then running it through a facial recognition thing to put emojis on people's faces. This is the next hottest startup. I am an angel investor. Disclaimer. No, just kidding. But it just kind of shows like how you can react to different events. Another very typical event that we see people reacting to is a user being added to the database. So DynamoDB, Amazon's NoSQL solution. When a new user gets added to the users table, let's say, you can then trigger a Lambda function to use Node Mailer to send them a welcome email. Like all of that can be done and wired up without like writing additional logic in your, let's say, Express app. You can just react to the events to basically build things faster. This is a really common one, and this is probably something that you guys will be doing today, where it's basically you have a UI, you go through API gateway, and then these might be like user CRUD. So, okay, create user, delete user, update user, and that all stores into a DynamoDB table. And then you might have another Lambda function that retrieves items from the database and shows it, puts it back in your UI. These diagrams, like these services can build out. This is a more complex example, but it's I like showing these diagrams because it kind of illustrates how you build out like larger applications. But basically, very similar concept. We have a couple of Lambda functions. One is actually sending an email confirmation. One is storing stuff into the database. And then we are doing some like dynamic image resizing and putting those into S3 buckets, etc. So this looks a little complicated. And wiring all this stuff together in your AWS account, it is by hand. And that's actually where the serverless framework comes in. Serverless framework's a free open source CLI that basically lets you define your application, where you want your code to run first. So this is the serverless.yaml file. I'll show more in a second. But basically, this is where you want your code to run. So in this example, I want to run in AWS. The runtime is Node. And these are the functions of my application. I have a save user. And then it's actually triggered on a HTTP request on a post. And then I also have another example here of make profile image thumbnail. So when a new image, when a user uploads a super large, like 3 megabyte picture of themselves, we can react to that event in our S3 bucket, create a thumbnail with your image resizer of choice, like Graphic Magic or what have you, and then put it back into a bucket. So you can actually use that in your UI, so your users aren't downloading ginormous files. That's just two really simple examples. And the code actually kind of looks like this. And we'll look at this more in a second. But super straightforward, just Node code with the Lambda kind of function signature there, which I'll talk about in a second. But yeah, so this is an example of just putting a user into a Dynamo table. Super simple, straightforward, and then it returns with a response back to the request. So yeah, so really we would use React. We do everything in React on the front end. Our entire site, all of our apps, all of our commercial stuff that we're working on is React because why not? It's awesome. And then everything back end we're doing with basically serverless functions and deploying those out. Yeah, so on the front end, you would use something, any Ajax library that you want. I like Axios. If you haven't used it yet, it's a promise-based one. It's really good. But yeah, you just basically plug in your API endpoints that the framework gives you back and call to whatever service you want. So if you're using the OpenTable API, for example, you can write a Lambda function to call and use the OpenTable SDK, let's say, do a request, get data, and spit it back to your UI. This is a really good resource. I highly recommend checking this out today, serverless-stack.com. This is an entire tutorial of how to build a robust React Redux and Lambda with Dynamo and a couple other things application. This is another project that I'll share the repo in the channel, but it's basically a React front end, and then there's a couple Lambda functions talking to a Dynamo table. That API looks just like this. AJAX request goes through API gateway, triggers my Lambda function that basically just uses the Dynamo SDK to grab stuff from Dynamo, then returns it back to the UI. So very, very simple use case. Cool. So let's actually look at this in action. So what we want to do, first things first, if you don't have the CLI installed, npm install serverless-g. Once you have that, though, whoops, I always do that. Yeah, so npm install serverless-g or yarn, whatever floats your boat. And what we want to do, once I have serverless installed on my machine, there's a number of different commands. And basically, like the framework helps you deploy your functions and wire up your endpoints. You can do that manually. It's very, very tedious, and you have to like zip up your code into a zip file and upload it, and it's, yeah, and set up cores and all kinds of other stuff that the framework kind of abstracts away from you. But yeah, so let's actually go ahead and create a new service. So with serverless create, I pass it a template. That template is Node.js because we're using JavaScript here, and I just put it into a demo folder, Reactathon. Cool. So let's look at what it actually looks like, the bare bones. So we have our serverless.yaml file, which again is the configuration, like where we want to run our code and what code we want to run, and like what events we want to react to. So it's basically this guy. So this is, yeah, again, an AWS node and a handler code. So let's look at the actual handler. Super straightforward, just regular JavaScript function that's returning a JSON body to the request. But let's actually wire this up to an API endpoint. So to do that, I have some code prepared for the sake of time. So right now, like if I deploy this function, it's only invocable programmatically. I want to expose this to the internet. I want to expose this to my UI. So the way to do that is by adding an event here. So I'm saying I want to have an HTTP event. I want the path to be /hello, and I want it to be a GET request. And I'm turning on cores for the UI so I can get stuff cross origin. But yeah, and then handler.hello references questions at the end. Module.exports hello, that's what that handler is actually referencing. But cool, so let's actually deploy this. So all I need to do is serverless deploy or SLS deploy. SLS is shorthand for serverless. That's typically what you'd use. So that's going to go ahead and create our stack. This does take about a minute the first time you deploy, because what's happening under the hood is AWS is we take your definition of your project, read all the functions and all of the different resources it may need. So if it needs a database table or an S3 bucket or API endpoints, which this one is actually showing, it needs to create the permissions for those and create the CloudFormation stack. Something out of our control, but yeah. So it is deploying. While it's deploying, I'm going to open up some other events that you guys can react to. So in our docs, we have, and for today, I'd probably recommend using AWS. It's kind of the most complete provider that we have thus far. and the most supported, and a larger portion of the market share in terms of cloud providers. But yeah, so we have a bunch of different events that we can react to, API endpoints. So this schedule event is actually a cron. So if I set up an event and told it to run this crawl function every 2 hours, it would go ahead and do that for me after I deploy it. Let's see where we are on the deploy process. IoT events, CloudWatch events, the S3 buckets like I mentioned. So basically this is an example of, okay, I want to run this users, so this file users.js, there's a function called handler in it. I want to run that every time a photo, or it could be a video, you could put anything into an S3 bucket. Anytime an object is removed from that bucket, trigger my function. So you could get notified if someone deletes a file or what have you. Cool. So that is still going, still chugging along. Let's see. While that's going, this is also highly recommended you check out github.com/serverless/examples. Pretty much all the different use cases and how to configure the serverless.yaml is in here. Users CRUD. There's an auth 0 example, which I highly recommend if you're doing any user auth today, especially at a hackathon. It's so easy to plug in and get basically GitHub and Facebook and Twitter OAuth into your app. But yeah, okay, there we go. It's back. So what we've just done is we deployed our code, and it gives us back this live API endpoint. And you can see here that basically I'm just returning JSON right now. I could return HTML or anything else, but let's actually add in some functionality real quick to demo this. So I'm just going to do a fake database call. So this is Star Wars names, a huge array of Star Wars names. I'm going to go ahead and grab a random array out of that. I'm going to get rid of that. The event that I'm logging out here, you can see all the post and get information. So when in doubt, console.log stuff in your request or in your logs, and you can see kind of all the data that's being passed in. But yeah, I'm going to go ahead and get rid of that guy. Change this to a string template. So we'll just do name, hi name, and that's syntax error. Cool. All right, so we just changed our code, and then I can just go ahead and do serverless deploy. I'm just going to deploy this function, which is much, much faster. I give it the function name. The function name is right here, hello. So I'm going to deploy that back up. There we go. So now if I hit that endpoint again, we can see, hi, Admiral Thrawn. Does anyone know Admiral Thrawn? I don't know who that is. I know Admiral Akbar. It's a trap! But anyways, I'm doing Star Wars impressions all weekend, so come find me. So yeah, so this is an infinitely scalable API endpoint that this is a really contrived example in the interest of time. But you can imagine calling into a third-party API. You can imagine, running Phantom.js to do something crazy, and basically do anything with that API endpoint. And then this is basically the URL that you would plug into the front end of your application for the AJAX requests. Is that exciting to anybody? Okay. I remember the first time I saw Austin, who's here as well, demo this before I worked at Serverless. I got like goosebumps, and I was like, oh my God, it's like live data, and I don't have to do anything with a server. But yeah. So cool. So definitely, let's go back to the presentation real quick. So check out serverless.com. Everything that we do is open source, including our website. This is built with React. I did a presentation on this at Pinterest about how we did that, and this is running on Netlify. So if you're using Netlify today, this might be a good reference as well. And yeah, we're here to help. So ping us on the Slack channel or come to our table. We have T-shirts and stickers, and yeah. basically come visit us. That's what we're here for. We do have a prize. So if you are using serverless in your hackathon project, $700 split amongst your team. Basically, we want to see the most interesting use case, someone using serverless in their project. Again, you can react to infrastructure events, set up cron jobs, set up API endpoints, do some stuff with IoT sockets, set up a custom Alexa skill. I mean, I could talk for 12 hours more about the different things you could do. And bonus points if you do some server-side rendering with a Lambda function, because I want to see that, and we'll probably want to use your code in our examples repository, because sharing is caring. But other than that, yeah, that's it for me. And go and conquer.
All right, let's give it up for David. To keep this moving along, all Q&A, just ask in Slack. With that, just 60 seconds, so bear with me. We just have one more announcement. An update to that Slack link. I think some people were saying the other one wasn't working. So here we go. This is a little more memorable. bit.ly Reactathon 2017-Slack. Also, just a note on the judging criteria for overall teams, which are going to be judged by us at Real World React, members from OpenTable, and members from Netlify. We're just looking for interesting, novel projects. Something that captures our attention, something that's cool, something that perhaps uses the APIs, but not particularly required. How well it's designed, how well it works, how much you get done, how much of the features that you wanted to include that you actually included. Obviously, if you don't get through all of the things you wanted to include in it, tell us about those things. And lastly, the presentation and pitch. And some people at hackathons say, why is that part of shouldn't it be all about the product? Well, you have to, communicate what the product is and what it is you're doing to us. So that's really important. We're not asking you to give a TED quality talk. We just want you to be able to say, okay, this is the problem, this is maybe the competition, or this is what exists now, and this is the solution. Walk us through what is going on. So around 3 o'clock at tomorrow, we'll go around to all the different teams, and you'll have 2 minutes to explain this to us, and then 1 minute of Q&A. So that's pretty much it. But if you have a team, feel free to go and start hacking. If you don't have a team, feel free to stick around here. Anyone who has an idea that they want to pitch to everyone, you have 1 minute to pitch with the mic. So with that, let's get going. Have fun.